right, we've got transformations of quadratic functions. And I know we've been skipping around a lot in chapter 2. We've got 2.5 and then 2.6, and then we'll be done with the chapter. So I have a picture of a rainbow, just so that you can remember that quadratic functions, most of the time they look like a U, but sometimes they're flipped upside down, and they look like an upside down U, or sometimes they look like a rainbow a little bit. Okay, a quadratic function is a function that can be written in the form y equals a times x minus h squared plus k. Now, this is really what we think of. This is the parent function, but this is what it would look like if we added stuff to it. And they have to put that down as the definition to take into consideration all of these things that we can add to it. But this is really the most simple thing. This is if a is 1, h is 0, k is 0. This is just the plain old simple one through the origin. Okay? The U-shaped graph of a quadratic function is called a parabola. I used to joke with my students and call it a parabola, and I think it drove them crazy. So it's a parabola. All right. So remember from the last lesson when we were doing transformations to lines and to absolute value functions. Now we're doing it to parabolas, to quadratic functions. Okay. A vertical translation, so this is up and down, it's f of x plus k. Now if we take the basic parent function of a quadratic equation, we have x squared, and if we plug that into this transformation, what we've got is we've got x squared plus k. So if that's the case, if we've just got a plain old parabola and it's just got to move up and down, that's what it will look like. Okay, on the flip side, if we've got a horizontal, okay, this is what the horizontal one looks like, f of x minus h. Okay, and if we've got f of x equals x squared, and we've got f of x minus h, that means we need to put x minus h in for x. So for a quadratic, it would be x minus h squared. So that's what it would look like for a quadratic. All right, so let's look at an example. Describe the transformation of f of x equals x squared, represented by g of x equals x plus 4 squared minus 1. Okay, well I recognize that right here I have something in parentheses. So I know that right here is going to be a horizontal shift. Now is it going to the left or the right? That's the question. If I rewrite this as x, well I have x minus h plus k. That's really what I've got going on here when I have the horizontal shift and the vertical shift. And what I've got here is x minus a negative 4. That's the same thing as x plus 4. Okay, so this is moving to the left because it's negative 4 units and down 1 unit. So if I graph my original, this will be my original function. Okay, instead of having to plot all these points, all I know is that it moved down 1 and it moved to the left 4. 1, 2, 3, 4. So that right there is what happened to that function. It went from the very middle and centered the vertex at the origin, and it moved over and down. Okay, and I knew that just by looking at this. Okay, so now I want you to try this one. So go ahead and pause. All right, so what we've got going on here, I'm going to rewrite it. I'm going to say x minus a negative 5 squared plus 1. So I know that it's moved, or did I use present tense last time? I don't remember. Moving to the left 5 units, right? Because it's a negative 5, and down 1 unit. Okay? So again, here's my original. And this is moving up 1 and over 5. 1, 2, 3, 4, 5. So it's basically like that. All right, so the reflections that we've got, when we're looking at a quadratic, again, we have f of x equals x squared. And if I'm just throwing a negative in front of it, then I have negative x squared. And remember, when we're using order of operations, if I have negative 5 squared, that means that the number is going to get squared first, and then the negative is going to be applied. So negative 5 squared is negative 25. Now, if I put it in like this is the same thing as saying negative 5 times negative 5, and that equals positive 25. So you can see the difference. And this one we'll see in the next video.